Taking a deeper look at remote access VPN technologies, different VPN technologies can be used depending on what it is that you're trying to accomplish. IPsec is the standard for site-to-site, but for remote access, it's what's been used traditionally, but what we've been, I don't want to call it upgraded, but we've been offered an alternative, which is commonly called SSL VPN. So when making the comparison, typically IPsec to SSL, remember site-to-site is always IPsec. But when we start looking at remote access, we've got these two options. Both of them are going to give you the same level of protection. Under the hood, they're both using AES for encryption. They're both using SHA for hashing. And of course, this is configurable. There's other algorithms you can support. But the protection mechanism is the same. It's really a difference in terms of the transport that you use. So IPsec leverages ESP. SSL is going to use either TCP for TLS or UDP for DTLS. And the deployment that you use is really going to be based on the type of connection that's being established. Clientless VPN is not going to be IPsec. It's going to be SSL only. It's using your browser. The AnyConnect can work as either SSL or an IPsec VPN client. Looking at Cisco's clientless SSL VPN client, this is going to establish a VPN simply leveraging the client's browser. So when we take a look at the clientless part, there's still a client there. It's a user, but they don't have VPN software client enabled. In this scenario, the Cisco ASA basically works as a proxy for external devices. They connect to the ASA, and then on behalf of those users, the ASA creates a connection to those internal resources. So the user establishes a VPN connection to the ASA using their browser. Basically, they'll hit a login page, they authenticate, and based on the group membership, they'll be assigned a VPN portal where accounting folks would see accounting services, people that are in sales would see resources appropriate for sales folks. The SSL VPN portal allows access to explicitly allowed set of resources. That is, whenever someone connects, we deliver them a page, and that page is a custom portal with this set of hyperlinks. These hyperlinks, the icon, the page, all of it, the artwork they see, the messages that are there, they're all going to be custom configured on a group-by-group basis or even user-by-user basis. So what we can do is say, well, when someone connects through clientless SSL VPN, maybe we're being more broad with what we allow to connect, but we're going to be more stringent upon the access, the resources that they're going to get access to. So I can say, for example, if someone's in HR, they have access to these resources and no other resources. But if you wanted to give them an exception to that, so they could do some browsing on their own, there's a feature that we can enable called URL entry. And it basically gives them an address bar, and they can define resources inside of the organization. So one approach is to lock it down so that they can only access the hyperlinks that you've provided. This isn't a bad approach. Two, we could say you can go beyond our hyperlinks with URL entry, allow them to go a little bit further. And then three, we could lock it down a touch further using something called a web type ACL. And a web type ACL just applies to SSL VPN traffic. So when the user accesses intranet websites via the internet, they're using a web browser. So they steer their browser based on URL to the ASA or Firepower Appliance's public interface. This is what's hosting the SSL VPN portal. So we connect in on TCP 443, we do our handshake, we negotiate SSL, we get delivered a page, and that page is going to be customized for us based on our group membership. Now, once you authenticate and you start accessing resources that are beyond that firewall, whenever I try to access the resource, I just type it into my browser, and then when that URL hits the ASA is going to rewrite it so that we can actually get to the web server. Then the same thing for the response. The URL rewrite option can be disabled if appropriate in your organization. So this is just kind of an overview of what a default SSL VPN interface is going to look like. Realize this is totally customizable. So up here, this could be your company's logo. The texture that you see is different. There's an editor that you can leverage from within ASDM Or if you want to build your own website, custom upload, you can customize the XML and then upload it to the ASA. So the configuration for this SSL VPN lives outside of your running config. It's a bit different, but it contains all the details for what users see when they connect. So they'll type, perhaps vpn.yourdomain.com. They'll have a login page. They authenticate, and then after they authenticate, they get these what we call bookmarks. So here's web bookmarks and FTP bookmarks. What you will do as the administrator is create a bookmark list. And the bookmark list, just like the name suggests, is a list of bookmarks, but you'd create one list for HR. You could create another list for your sales organization. You could create another list, maybe for tech support. And again, when users from these departments log in, they'll have different capabilities. For example, what you see up here with this URL entry bar, this is really a feature. This is something that can be granted or taken away, but it gives the end user the ability to browse if they know where they're headed inside of the organization. So a step beyond using the clientless solution where you just use your browser is to install Cisco's AnyConnect VPN client. If you weren't already aware, the Cisco AnyConnect client is good for VPN, but it also handles 802.1x, which can be leveraged for local authentication over both wired and wireless connections. So it should feel fairly similar for the user to log in, whether they're local or remote. Basically, they'll kick off Cisco AnyConnect. Cisco AnyConnect will prompt them for credentials, and they'll log into the network. When they log in, the AAA server, the firewall, the switch, the router, they will have a discussion about what the appropriate level of access is for that user, and it will be applied to that user for their session. AnyConnect is supported by both the ASA as well as Firepower. It supports IPsec as well as SSL VPN. SSL is going to use DTLS and TLS under the hood. And remember that it provides a direct and full access VPN connection. That is, any type of traffic, any application that you want to send across, it's going to go ahead and encapsulate that and pass it through, where the clientless VPN had some limitations. So the two basic VPN deployment models that you have to choose from are going to be either IPsec or SSL. If it's site-to-site connectivity, there's not really a choice. We just use IPsec, and then we pick a topology. Maybe we use DMVPN, maybe we use VTIs, but it's still going to be IPsec. SSL really just becomes an option for remote access users. In modern days, we say that SSL is going to be preferred over IPsec. Is it more secure? Nope. Is it less overhead? Nope. All it really has to do with is the fact that it's more likely to work through firewalls and proxies that are out of our control. Do other people know to allow UDP 4500 through? Do you remember what that was for? NAT traversal. So if we're doing IPsec over UDP so that we can go through a PAT device, this can actually be automatically detected whether or not it's necessary using NAT-D, NAT detection. We'll say, oh, we see NAT is in use. Let's encapsulate our ESP packets inside of UDP headers. And you can do that. But again, if there's any type of filtering, does that administrator know to allow UDP 4500 through? If they don't, your users aren't getting their job done. So coming back to SSL VPN, this is going to use TCP 443, very likely to be allowed through. Additionally, DTLS or datagram TLS uses UDP 443. Your initial connection will be on TCP 443. It should always work unless you're doing some type of intercept. If TCP 443 connects, we set up our tunnel, it's going to try to leverage DTLS. It says, hey, we could actually do less overhead and get rid of duplicate retransmissions if we leverage UDP. This is where DTLS comes in. So we move from TCP 443 over to UDP 443 once a connection is established. But if we start encapsulating in UDP 443 and we sense that we're not getting any type of acknowledgement, any type of data back, we'll fall back to using TCP. This is called DTLS fallback. And we do this because UDP 443 may not always be allowed. just like UDP 4500 may not always be allowed.